This is Corey Willis with PPEI, and you're listening to the Diesel Podcast.
I'm Adam Blattenberg from Diesel World.
This is Dan, owner of Dan's Diesel Performance.
I'm Cass from Diesel Doctor of Tennessee, and you're listening to the Diesel Podcast.
What is going on, Diesel Nation? We're excited to have you guys with us today on the #1 diesel truck podcast on iTunes. Today we're talking about something that everyone's going to find interesting, no matter what either part you're looking for or part of the industry that you're in, and that's the term billet. And today we're going to be chatting with the owner of Precision Converters, and he's going to be telling us about what billet is, specifically because he's got hands-on experience with it, with what they do with their torque converters and other components, the different materials that you can use, which materials are good in different applications, and how that all fits together into the diesel aftermarket. So we know you guys are going to love this episode. We wanted to let you know before we get to it about our Patreon page. We had been asked for quite a long time from a lot of our fans out there, hey, how can I help you guys? So we created different tiers. And if you guys are looking for a way to support the podcast, help us out, you buy us a coffee while we're editing episodes late at night, just go to Patreon and search the Diesel Podcast. You'll find the tiers there. If there's any suggestions that you guys have for either different giveaways or different things that you'd like to see, just let us know. You can find us on Instagram, on Facebook, or you can email us at info@thedieselpodcast.com. All right, let's get to the podcast with Terry from Precision Converters, talking about billet, talking about torque converters, and tons of other things related to diesel performance. Terry, welcome back to the Diesel Podcast. I'm excited to chat with you today and ask you a bunch of different questions about installing torque converters and then kind of getting into the nuts and bolts, so to speak, of the internals and what the word billet really means when it comes to a converter.
Sure, fine. Glad to talk to you, Patrick.
This is kind of a series of questions that we've gotten from, I'd say, mostly installers because they're doing it all the time, but also just some truck guys out there that like to work on their own trucks, and it's specifically, with the converter. One of them that we get is, should I pre-fill the torque converter when I install it, or does it need to be pre-filled, or what should they do in that situation? So I wanted to ask you, what does Precision recommend when they get, guy gets a brand new converter? Do they need to pre-fill it, or can they just install it in the truck and once they turn the key to on, the pump's going and it just fills it up?
Okay, well, why don't I'll go through the whole procedure of installing a converter. How's that?
That works perfect.
Okay, number one, before you install any converter, brand new converter, you should probably pour a quart of transmission oil into the impeller hub. That will lube the bearings and everything, especially if the converter is installed dry. That'll be the first thing we do on an install.
Okay.
The second thing is, with the transmission out of the vehicle, if you have it out, let's say it's a fresh rebuild, and you have it out of the transmission, the correct way to install a torque converter is to stand the converter on the tail housing, having a helper hold the trans. Gravity will install a converter for you. That way you can make sure it's all the way on. You can rotate the converter and gravity it'll drop down the two splines and into the pump gear with no problem. The problem is that when you get ready to put it on a transmission jack, you have to be careful that the converter does not slide forward and come out of the pump gears. You just have to make sure of that. Now, if the transmission, you're going to install a converter with it in the vehicle, and let's just say a lot of guys do because they have a transfer case hooked on the back and it's sitting on a transmission jack, and you don't want to mess with taking it off and removing the transfer case. You can install the converter this way, but you have to be really careful. First of all, gravity is fighting against you. When you get it on the input shaft and stator support, the front of the converter, the pilot side of the converter, is going to want to sag. So what you're going to have to do is pick up the converter with the pilot and slowly rotate it and make sure you get it all the way in through the first two splines and into the pump gear. Now, how do we check this to see if we've got it in all the way? Well, you can check the distance from the transmission bell housing surface down to the pad that would touch the flex plate. This dimension needs to be approximately 1/8 of an inch and a 1/16. If that measurement is less than 1 inch, the converter is not all the way installed into the front pump. It may be on the splines, but it's not installed in the pump all the way. And if the converter is not installed correctly, this will cause catastrophic front pump and torque converter impeller damage. After you get it installed and you're going to put the transmission up to the back of the engine, once you get the transmission up and touching the back of the engine, the converter should rotate freely by hand after the transmission bell housing is flush with the back of the block. And never use the bolts to pull it up against the back of the block. If that's necessary, you probably don't have the transmission in the front pump. They should just slide right up on over the dowels, up, flush with the back of the block, and then when you can reach in and rotate the converter, you're in correctly, you've got it installed correctly. And after you get the transmission bolted to the back of the engine, you want to check the pull-up. That's what I mean. When the converter is all the way installed in the transmission, after you've got it bolted to the back of the engine, you should be able to pull the converter forward at least 80 thousandths of an inch, but no more than 187 thousandths. If it gets more than 187 thousandths, you're going to have to use washers, equal thickness washers, to keep it from pulling forward more than 187 thousandths. If you don't, it's going to want to pull the impeller out of the front pump and causing damage. The next thing on the install is you want to install all the converter bolts by hand. You put them all in by hand. After you get them all in, then torque them all to 30 foot-pounds. If you put one bolt and get it started, and you don't happen to get it started on the starting hole, which is on most bell housings have, what will happen is, as you put the bolts in, you won't be able to get some of them in because the bolts will not line up with the holes in the flex plate. Now, I've seen a lot of guys do this. They try and get it started, and then they pull them in with an impact. And what that does, it destroys the threads in the converter, and we have to start all over. But after you get everything installed and you think you've got it installed correctly, make sure you have transmission oil and a funnel to immediately start putting fluid in the trans as soon as the engine starts. This will help prevent impeller hub damage. Before you do this, you're automatically going to put at least 6 or 8 quarts in the trans before you start the engine. But even after you have that much oil in the transmission, the problem is you've got an empty converter that holds about 4 quarts. So as the engine starts, it's going to want to fill the converter, and the impeller hub and bushing are going to run dry. So make sure that you immediately start adding fluid as soon as the engine started to prevent damage. And that's what I recommend on doing an install in a converter.
There's a lot of good tips in there too, because we'll hear stories, or just in reading, or just being around, shops and people doing stuff in their trucks, is we'll hear, the pump seal is leaking, and they get the transmission installed, and then it's like they got to pull it back out, and that's time and labor. But if they take the time, like you mentioned at the start, to make sure it's seated, correctly, then you just avoided a few hours of work or even more, and having to put a pump seal in. And
yeah, if you install it incorrectly, you're going to be doing more than putting a pump seal in. You're going to be removing the pump out of the trans and replacing the pump because the pump gear bolts have broken. And when you go to start it up, all that stuff gets bound up inside, tearing the pocket that's inside the front pump to pieces and destroying the hub on the impeller hub on the converter. which that's going to be really costly because now you're going to have to send the converter back to the person that built it and have a new hub put on it. Plus, if you're not a transmission expert, you're going to have to haul the transmission down to the transmission shop and have them put a new pump in it because the pump is going to be severely damaged. And that's what I mean by catastrophic failure.
Yeah.
It's going to be time-consuming, and it's going to be very expensive. All you've got to do is take a little bit of time and do the steps that are required, and you'll never have a problem installing converters in the transmissions and getting them installed behind the engine correctly.
I think the fluid level and filling it as the truck, well, before the truck starts and then while it's idling there in the bay is also really important as well, especially making sure, when it says full, it's really at full because there's...
Oh, yeah, that's correct. Well, before you do anything, once you get the transmission installed, like I said before, put 6 to 8 quarts in the pan. Most diesels hold around 12, 13, 14 quarts. But if you try to pour 8 to 10 quarts in the trans before the engine started, now it's probably going to start bleeding out the air vent and making a mess. So put about 6 to 8 quarts in it and get ready with your oil and your funnel. And as soon as the engine starts, start pouring oil in. And what you want to do is you want to fill it to the full line, run it through the gears, take it out on a road test, come back and recheck the oil at the level. And make sure that it's at the full mark. Once you've done this, you're ready to roll. You're ready to go.
Yeah, sometimes there's some stories or we'll get messages from people and they'll say, I've been having issues with my transmission, and it's like, well, how much fluid have you been putting in it? And it's under what's recommended, and that just causes it damages the whole thing, not just the converter, but also the transmission, and then it's really expensive to fix that. So, just like you said, taking a little bit of time and following those steps can help a lot of the shop owners that are out there, but also the guys who work on their truck and maybe they get the transmission and converter and they're just installing it themselves. So that's some good information.
Yeah, there's no rule of thumb of how many quarts a trans holds, because your transmission may have an aftermarket pan that holds more than stock.
That's true.
The other thing is the converter that you're using, may take more oil in it. It's definitely, if it's a multi-disc converter, it's going to take more oil than the stock converter. So looking in the owner's manual and say, it takes 12 quarts, that doesn't mean anything, because a multi-disc converter will take approximately 2 to 2.5 more quarts than what the factory specs call for. So the best way to do it is to fill it until the dipstick says full. Now the dipstick, when on the full mark, is right when the oil levels is on the full mark on the dipstick. That means the oil is level with the pan rail. So if you have a dipstick that you're not sure whether it's accurate or not, you want to fill the trans full, and if you're worried about it, loosen the pan and see as you loosen whether the oil comes out around the gasket. If it does, then it's full. If it doesn't, that means your dipstick is not correct, and it should be altered so that that the level meets the specs. Now you can do this by putting the dipstick in the transmission before you ever install it with the pan removed, and look and see where the full mark is. The full mark should be right even with the pan rail. The pan rail is the part where the pan bolts up to the case. That way you make sure you have the correct oil fill. The second thing is, a lot of guys say, well, I've got it full, let me put another quart or two in it just to be safe. The problem with that is, once you overfill it, Now you've got the drums and everything running in the oil, causing it to foam because it's foaming the oil in the inside. It's got to go somewhere.
Yeah, that I've heard that a few times. Overfilling it isn't good either. Either it has to be right on, can't be under or over, or there's problems that happen. I know with the bolts, some guys they'll Loctite them. Do you need to Loctite the converter bolts, or are they designed in a way where you don't need that as long as it's torqued to the proper specification?
You should use Loctite on them, just to make sure, especially in diesel applications because of the engine pulses vibrating everything. But if you torque them to 30 foot-pounds, 30 to 35 foot-pounds, they will not come loose. If they come loose, it's because your torque wrench is off, or they didn't get torqued. They just got tightened hand tight. But I always recommend using Loctite.
Should they use red Loctite or blue?
Yeah, use the red. It's fine.
Okay. This kind of leads into another question I was just thinking about when we were talking about the converter, and admittedly I'm confused a little bit on it as well, but you guys make so many parts, you know exactly what's going into the converter, and you're specifying them and machining them and doing them all in-house. But we hear the term billet a lot, and it's all over the automotive world. But specifically with a converter and the cover and the other parts you're using, and just kind of jumping into the technical side of it, is how important is the material that you're using? Why do you pick that material? What does it do for, one, maintaining the tolerances, which we've chatted about before on the podcast, how important those are, and just making sure that product, that they get it, that it's going to perform and last and do what they need to do. But I really want to jump into the material side of it and just kind of pick your brain a little bit and get some insights into that.
Well, a lot of the people in the industry are not going to like what I say. Billet, there's nothing secret about billet. Billet is just a piece of bar stock, whether it's a steel or aluminum. It's just a regular old piece of bar stock. That's all it is. There's nothing secret. There's nothing special about billet. The name billet, in the industry is an old wives' tale, that it suggests that it's something special. Mm-hmm. It's nothing special. It's just a piece of bar stock. If you buy a 2-inch diameter piece of steel bar stock, let's say 1018 or 1045, and you cut off the piece and you're going to machine a part of, yep, that's billet, but that's all it is. The term billet, is a misnomer. It's just a piece of bar stock. And if you don't believe me, Google it. Go Google the word billet. It's nothing special. The industry, for some reason, years ago, tried to pull the wool over a customer's eyes. Oh, this is billet. This is special. Billet is just metal that the parts are machined from, period. Now, there are different grades of bar stock. There's, 1018, 1045, 4130, 4140, ranging, 300M, ranging 300, Inconel, all that, all the different kinds of bar stock. And all of it can be called billet. It's just bar stock that you machine parts of.
That's what's so refreshing to hear, and I know our listeners are going to appreciate that, is that term is everywhere. And sometimes I'll read something or I see something, and I think one of the biggest ones is, well, I've got like a full billet transmission. Well, what's full billet mean? Like, what is it? What are we talking about? Are we talking about the shafts? Are we talking about the converter? Are we talking about the cover, the stator? All those sorts of things. And I'm inquisitive, and so my mind goes to, well, what is the material? Why did they choose it? And with a precision converter, that's what I wanted to ask you about, the cover and the other parts you guys are doing, is when someone buys a converter, what are they getting, and why did you guys pick, say, that certain type of steel or aluminum to be able to make that converter?
Some converter manufacturers use bar stock, which is, what they call billet. They use that to machine their stators and their front covers. And that's all well and good. Other converter builders buy castings from the Chinese to make their covers. Cover castings are totally inferior due to the porosity that they can have and the uneven density, which make them very, very hard to balance. So if you run across a casting cover used on a converter, I would recommend staying as far away from that as you can get. We use only high-quality forgings for our converter covers, our impeller hubs, our turbine hubs, our input shafts, our flex plates, our clutch drivers, our forward drums, our intermediate shafts, and our stator races. Forgings are far superior to bar stock, or what the industry calls billet, or castings.
Mm-hmm.
Unlike bar stock or castings, the grain in forgings follow the shape of the material, making it extremely stronger, while the grain in a bar stock is only in one direction, and in castings, who knows what direction it's in. By machining with forgings, it saves machining time, and it saves material waste, allowing for the cost to be passed on to the customer. And that's why we use only high-quality forgings, period.
You'd mentioned balancing, and it was just a question that popped into my head right now, is if a converter's out of balance, which is in a way relating to what we're talking about with a casting on a front cover or something like that, what does the truck owner feel if the converter's out of balance?
Well, number one, the converter has to be balanced. The total converter, a total rotating mass, has to have no more than 12 grams out of balance. If it has more than 12 grams, you can feel it at idle shaking the truck.
Okay.
Now, our converters leave here with no more than 4 grams. The factory, allows them up to 10 to 12 grams. But you can tell if you look at a converter and it has no weights on it at all, either, everything has been balanced internally in the converter or it hasn't been balanced at all. And what we do is we balance the turbine and the clutch together, and we balance the impeller separately, and we balance the cover separately. So as we match all of these together, putting a little bit of out of balance on one side of the converter compared to the other side of the converter, sometimes we can get away with no balances. But usually we end up with around a 5 gram weight on just to get it down to zero as close as we can. Balance is critical, absolutely critical.
I remember I had a friend once that he just bought a truck, and I think it had an aftermarket transmission. It was a 48RE, and the thing would just kind of shake at idle. And it was like, there's a million different directions, you could go with it. What's making it do it? Is it the engine? Is it the, converter? All these different things. And it ended up being the converter. I don't know anything about the build or what it was, but I know that's a question that can kind of pop up a little bit, especially after, a new transmission install, new converter, things like that. And I think the balancing can be overlooked in, the performance side of things or the aftermarket. From the consumer standpoint, is why is this important? And even what we talked about with the materials and what is billet and the different kinds of material that are out there is why it's so important in a way. Like, with a converter, as a truck owner, we don't necessarily think about it that much, but we're feeling it every mile that we drive, whether we're towing, daily driving, racing, whatever it is, and how important it is in the performance of the vehicle and the driving experience. And there can be so much confusion out there, I think, because it's a very complex part and there's so much involved in it. But it's refreshing to be able to, sit down with you and ask you these questions about it. So whether it's a shop or an individual that is putting in a converter, they know what to ask, they know what to expect, they know how to get it installed properly and make it as seamless as possible to get into the truck and then enjoy it.
Yeah, well, a lot of guys that do OEM type converters, and they mark the converter before they cut it open to make sure that they put the weight back in the right place. Now that weight is there for two reasons. That weight, if the converter is a little bit out of round, it's going to require weight on one side. If they put it back together correctly and it's not out of round, let's say it's within 4 or 5 thousandths run out, now that weight has got to be cut off and rebalanced, because if you put it back together, you're going to end up with an out-of-balance converter. Now, aftermarket parts that are made from bar stock or forgings or whatever, a lot of guys look at these things and say, well, hey, the cover was made on a CNC machine, blah, blah, blah. What they don't realize is that a lot of guys send parts out and have them furnace brazed. Furnace brazing is done by taking a device that looks like a hypodermic needle and putting the flux in all the cracks and all the holes, and then it's run through about 1,200 degrees to melt it all together. The problem is, if the person putting the flux on is sloppy, okay, that flux will melt down and it'll be heavy on one side. So now you're going to have to rebalance it, to start with. So there's a multitude of reasons why you have to balance a converter. And a lot of guys, I don't know whether they don't have balancers or they think it's a waste of time, because it's not easy to balance a multi-disc converter due to the heavy weight of the clutches and dragging on the inside. It's not easy, and a lot of guys just say, well, that's close enough, let's ship it out the door.
Mm-hmm.
But, that's not the correct way to do it. They may get away with it, and then again, they may not. So, it's all up to them. I know one thing, ours leave here balanced.
Well, it's really important, because it's a big risk. Like as a truck owner, is if I'm going to order something and have somebody install it or do it myself, I don't want any guesswork.
You don't want to have to take it back out,
Yeah.
Especially the guys trying to do it in their driveway. My God, that's a day's work, and then to turn around and have to take it back out. That's terrible.
Yeah, that's when people get upset.
Yeah. I really don't recommend anybody doing that, because it's very, very dangerous. Yeah. You got a 6,000 or 7,000 pound truck that you got up on blocks or on stands or whatever, and one mistake, and you got a 150 to 200 pound trans and a 100 pound transfer case on your chest, in a heartbeat, and you're dead. So I don't recommend doing it in your driveway. Pay the extra money and have a professional do it. Because let's face it, if he screws up the install, you don't have to pay for it.
Yeah, that's true. Yeah, and that's a really good point too about the safety of it. Where you take it to a shop, it's on a lift. There's a transmission. You're able to support the transmission in the transfer case and all that sort of stuff. Versus on a driveway, it's totally different.
I hear this every once in a while about, a truck being up on blocks. They had it in park, okay, and all of a sudden they take everything loose. They take the driveland loose, and all of a sudden now the truck starts to roll. And if you're underneath this thing, you don't have time to get out of it.
Yeah.
Because once that 6,000 or 7,000 pound vehicle starts rolling, and you try to get out from underneath it, it's liable to roll over your leg and break it. Who knows? So, these things are so heavy and so cumbersome, And when you try to do it on the ground, and you know, whether you have a transmission jack or you got it on a floor jack with blocks, and you try to bring it up against the back of the engine, odds are that converter is going to want to slide forward. And if it slides forward, it's out of the pump. And now you've rassled it, and you get it up to the back of the block, and let's put some bolts in it, and let's take a ratchet or impact and let's pull it up against it. Well, once you've done that, you destroy the impeller hub and the front pump. Now you got to start all over and spend a lot of money. You know, for years I was in the transmission business and the torque converter business. We only do specialty torque converters now, but you kind of see everything.
Yeah.
You know, a truck comes in or a car comes in on a chain, you know, with the transmission in the trunk, and then now they want you to fix it, but they want you to do it for peanuts, and then that's just, you know, it's not my fault that it got the condition it's in. It's your fault. And but I've after 35 years of this, I've seen it all.
Yeah, there's a lot of feedback that we get and just conversations we have with listeners out there, and they're all, you know, some of them are business owners, shop owners, some of them are guys that like to do as much work as they can, and we've had those questions pop up about the billet and how to make sure we don't damage the pump or the converter during install, and there's some really good insights and tips, and I had to kind of ask about the fluid fill, because I know that's at different times, you know, a guy will be like, oh, it was totally full, and then the transmission and converter get toasted, and it wasn't, because it just didn't get up to operating temperature, wasn't driven, and just, you know, checking those things out will ensure we spend a lot, you know, these big amounts of money on something that...
Yeah, just take your time. Take your time and double check. You know, double check. That's, you know, that's what the guys in the trans shop do. Mm-hmm. You know, they have systems. Their R&R people have systems. You know, they double check and triple check, you know, cooler lines, that the converter's in property, you know, that the drive shaft to center support's correct, et cetera, et cetera, et cetera. The other thing I'd kind of like to dwell on about let's get back to the billet thing here a little bit.
Yeah.
You know, a lot of guys that do stators and covers, you know, they use billets, which is, you know, bar stock. Now, for our stators, we don't use bar stock because it takes up too much time. Our steel and aluminum stators are investment cast, which saves machine time and material waste. The investment casting designs can be altered quickly. Do a simple change in the die shape, saving time and machine time. You know, investment castings can be made a really high volume, while machining one from bar stock, or a billet, as everybody calls it, can take upwards of hours. And the problem is that unless you use 5-axis, most guys use 4-axis, the shape of the blade on the stator is not correct. There's a reason, if you take a look at a stock stator, why one side of it looks like an airplane wing and the other side doesn't. You know, this is there for a reason. You know, the factory people, the factory engineers, are not stupid. If they didn't have to do it, let me tell you, it would save them pennies on millions of pieces, and they would quit doing it. But that's why we use investment casting. We use our 5-axis machine to design prototypes, and we test it in our test mule to make sure everything is right the way we want it. Once we get it where we want it, then we have a die made, and we investment cast those. And that's the way, you know, instead of using bar stock, that's the way we do our stators.
Those are some good insights. And it's what I think jumping into the details of these different components is what I love, I know our listeners love it, is this: we get hit with marketing all the time, or we get like the catchphrases or just the real kind of simple explanations, but there's so much that goes into these, like into a converter, with what material you're choosing, how it's being machined, the balancing that we talked about. I know in some other episodes we've talked about the multi-disc clutches and all those sorts of things, and there's a thirst for that knowledge and wanting to know more about how this works. How does it relate to ultimately driving the vehicle? And that's what's so cool, to be able to ask you these questions and chat about the converters and learn more about them.
Yeah, well, torque converters, when you first cut one open, they look really simple. You got an impeller, you got a turbine, you got a stator, some bearings, and if it's a lockup, you have a clutch and some clutch lining and a front cover. And everybody looks at it and says, oh, well, this thing is pretty simple. But in reality, they're not. A lot of things depend on how the torque converter works. And a lot of people have no idea how the converter works. What they do is they open up a competitor's converter and they use, a lot of guys just copy it and say, oh, well, yeah, now I'm the converter expert. That isn't the way it works. I learned converter technology when I worked at Chevrolet Research and Development. We went through a lot of different designs, and I learned a lot about transmissions and torque converters. But let's just say on the impeller, a lot of guys will take a converter and they want it tighter, so they crank the vanes, to 45 to 50, degrees positive, which what it does is just aggravates a big problem. It makes a heat pump out of the converter. Because when you bend those vanes from like 30 degrees positive to 55 degrees positive, now the clearance between those blades and the turbine is a lot greater than it was when it was 30 degrees. At 30 degrees, you might have had 100 to 125 thousandths clearance. You bend those vanes positive, now you got 250 to 300 thousandths clearance between the turbine and the impeller, and for every 80 thousandths of clearance, you increase the stall speed. So what you're doing is you're really kind of defeating your own purpose. You're making a heat pump out of it, plus you're not getting the desired what you're after. And a lot of guys are horsing around with the turbine, which is a total waste of time. Again, the factory engineers are not stupid. They've got it designed so that the hydraulic energy is changed into mechanical energy with the hook shape that's in the vane in the turbine. And when that turbine oil comes out of the turbine, it's going backwards to rotation. So that's why we need a stator. We need a stator to turn the flow around to the direction that the converter is rotating. When it does this, it exits out of the stator and pushes on the back side of the impeller, which is where we get our torque multiplication from. A lot of guys, to get higher stall, they're going to kill the torque multiplication. So they cut the vanes off on the impeller side, and all that does is generate more heat. Because now, instead of the oil flowing through the stator in a direction of flow, it's flowing straight through the stator, and as the impeller turns, it's shearing the oil, generating massive amounts of heat. So it may be okay going down the road when the converter clutch is locked up, but in town driving without the converter clutch locked up, that's where you start seeing temperatures of 250, 275, 300 degrees, and they can't figure out why. It's because the design of the converter has been altered in such a way that it's defeating its own purpose.
There's so many things there that, we did, I chatted with Cass from Choate Engineering recently, and he was telling me about, in his shop, he likes to do this thing where before the truck's diagnosed with whatever it's in for, he likes to try to figure it out beforehand. just, I think, to test himself and just to, see, hey, can I, figure out what has happened inside this engine before we even get the head off of it. And I was thinking about some of the things you're saying there with like the heat and different symptoms that people will talk about with their torque converter transmission, the truck, that right there is where you can almost diagnose it. And I think that's where a lot of the questions come from with shop owners and truck owners is, well, the transmission's running hot. Well, now we have to ask, well, what's done with the converter? What was changed? How was it altered? Like you mentioned, where it can be that you try to achieve this goal, but if you don't do it the right way, you're basically just building heat in it. Or why is there this vibration at idle? Why is when I put it in drive and I'm just starting to take off, I get this shake? Well, there's so many parts of the converter that if they're not done right are going to show these symptoms. And with the information that you're giving about it and educating us, is we can see almost what the issue is before, pulling the transmission out or, going through a lot of time and labor and money and that relationship between the two. And that's what's really important about the converter and what we're talking about is if it's not done right, you're going to have a bunch of these other issues. And I know there's people that spend a lot of money trying to figure out why is the transmission running hot, and they might not look to the converter till the very end, or they, just got something, didn't ask any questions, threw it in there, and, now it's running 220, 230 degrees, and that's going to be an issue eventually.
Yes, well, a lot of guys that install big turbos need a converter that'll stall up easier. And a lot of torque converter builders try to take the Cummins type converter and alter it so that you can get, high stall out of it. This is virtually impossible. The impeller in a Cummins is about 50 degrees positive. Plus, it's all furnace brazed. So if you go to try to alter the vanes, you start ripping the vanes, and then you're going to have to go in and try and TIG weld them. The other thing is that the torus, which is the turbine, the torus in the turbine, to make clearance for the clutch, what Borg-Warner and Chrysler decided to do was to make the turbine flat. And it loses its capability of generating high speed so that it can do, it can have more torque multiplication through the stator. So therefore, the Cummins converter is strictly a low stall, low torque multiplication converter, and there's nothing you can do with it. We don't use a Cummins converter to make high stall. We use a different converter. We don't use any Cummins parts in that converter or in any high stall Duramax or Power Stroke. We make the converter, the customer comes to us and asks, well, I think I need this or I think that. We take the information, and then over 25, 30 years of experience, we build what it think it will work. And sometimes 90% of the times we hit it, sometimes we don't. That's why we have a free stall change. Now, the old wives' tale is similar to the Billet wives' tale, that every diesel needs a low stall converter. This is absolutely not true. An inline six tractor motor like the Cummins is, let me tell you, a low stall converter is a sweetheart in that particular application. But when you go to a V8, like in a Duramax or a Power Stroke, you put a Cummins converter in that particular application, to convert a Cummins style converter, you have the biggest dog away from a stop sign that you ever can imagine. I've driven them where you want to open the door and put your foot out and help push it to get it away from the stop sign. So you should talk to a converter builder that is knowledgeable with these. Every McDonald employee is an expert on diesels on the internet. And, that's the last place you should look for advice. You don't go to a tile layer and ask if you need a penicillin shot. It's just the same way. You don't go to somebody that's learned all there is to know on the internet, and of course the internet is all true. You go to a professional that makes these things and develops these things. He's going to try to do the best job he can for you, because he doesn't want a customer that's upset or to see the thing come back. And so that's my advice to anybody that's buying a converter. And make sure that whoever you deal with knows what they're talking about. It's just, you can talk to a guy and say he can give you a line of bull or whatever, but intelligent customers can see through a lot of this by asking questions. If you want a high stall diesel converter, what core do you use if I've got a power stroke? To use the Cummins core, what do you do to it? And what kind of stall do you think I can get out of it? Our high stall converters for the diesels, it's very easy for us to get 4,500 to 5,000 stall for the guys that shift their diesels at 6,500 or so. It's also easy for us to make a converter stall at 16, 17, 1,800 also. But that isn't for V8 diesel engines, period. And then when you start putting bigger turbos on it, you move the power band up so you have less low end. So you're sure as heck not going to want a tighter converter. You want something where it can get up on the turbo and make boost. Simple as that.
I think this episode definitely helped, answer some questions, but then also help the people out there ask the right ones, as well. So this is a really informative podcast, and I'm sure there's going to be a ton of other questions I have for you some other time based on it. But it's just so cool to be able to chat about what makes these things work and how they can work well or not work well, and what we need to ask.
Well, we're here. We're not going anywhere. If anybody wants more information, you can call one of my sales staff, Jack or Todd, and they'd be glad to help you out. They're going to ask you questions about your truck, about the engine, about everything, and kind of give you a recommendation of what we think will work. And it doesn't cost you a thing. Give us a call, and our 800 number is 800-649-7866. And just ask for one of the sales staff, and we'd be glad to answer any questions you have.
Well, we appreciate your time today, Terry, and your expertise as always. And
yeah, it's great talking to you, Patrick, and thank you. I appreciate it.
Don't forget, Diesel fans, make sure and head on over to Patreon, search the Diesel Podcast, check out the different levels that we have. There's different giveaways and kind of insider information that we can give you guys for the podcast, and including you guys in it as well. So if there's a segment or questions that you guys specifically want us to ask a guest, you can share those with us, and then we can work them into episodes. Till next time, keep the shiny side up.